class. Today we're going to talk about something really cool. It's something that we experience every day. What could that be? I'll give you a hint. It has to do with this. It's sound. Today we're going to talk about sound. So I want you to think of your top 3 favorite sounds and pause the video and take a moment to write those down. Good. Now I want you to think about what could cause those 3 sounds. Well, if you're not sure, we're going to learn about that today. So, sound is produced by something called a vibration. And a vibration is a rapid back and forth motion of matter when it produces and transmits sound. So take a minute to pause the video and I want you to write this definition down. Now, if I were to stretch this rubber band out and strum on it, it makes a sound, right? That sound is called a sound wave, and the sound wave is caused by a vibration. So any sound is just short for sound wave, and a sound wave is produced by a vibration of an object. So the way that sound travels is through compressions. These here are compressions, and a compression is a region in sound wave where particles are closest together. Like here, you can see we have compressions. And then these here are called rarefactions. And rarefactions are regions in sound waves where particles are the farthest apart. So I want you to take a minute to pause this and write down these 2 definitions. Now, I want you to go back to your notes and I want you to draw your own sound wave. Write down where you draw your compressions and rarefactions and label those. Good. Now that you've drawn your sound waves, I want you to draw a bracket from one compression to the next compression. And then I want you to do the same thing from one rarefaction to the next rarefaction. These are called wavelengths, and wavelengths is the distance between 2 compressions or 2 rarefactions. And wavelengths help us to determine the pitch of a sound. So what's a pitch? Listen carefully. I'm going to make 2 sounds and they're both going to be different pitches. So here's the first sound. Ee! And here's the second sound. Ooh. Do you think one of those sounded higher or lower? I'll do it again and then go back to your notes and write down, circle whichever one you think was the highest. Ee, ooh. Now, I want you to pause the video and I want you to do your own sounds. As you're doing these, do the same ones that I did. If you need to go back and listen again, you can. But put your fingers on your throat and feel which vibration you think was faster. So make both types of sound and see what you think. So which one did you think? Did you come to the conclusion that the higher your voice went, the faster the vibrations were? Well, the faster the vibration means the higher the sound. That's called a pitch. The lower the vibration is, the slower the vibration is, the lower the sound. So now I want you to draw a picture that could represent this sentence in any way that you can think of. The faster the vibration, the higher the sound. So you can draw vibration however you want, and you can draw sound however you want. So pause the video and do that now. Now I have one last word for you to learn today. And this is a word that's used a lot with instruments, especially guitar, like instruments that get loud. It's a word you've probably heard a lot, and it's the word amplitude. Amplitude means that the more vibration, the louder the sound. So if you have a lot of vibration, then you're going to get a lot of sound. And if you get a little bit of vibration, it's going to be a quieter sound. So I want you to draw a picture of what you think might represent more vibration is a louder sound. I'm hearing some similarities between amplitude and pitch, right? So I want you to think about that and pause the video and write down in your notes one similarity you can think of between pitch and amplitude, and one difference you can think of between pitch and amplitude. great, class. It was so much fun learning about this. Now, I want you to remember everything you've learned today so that you can come in tomorrow and we're going to do a really cool experiment to discover other factors that can affect the speed of vibrations.